Hi, everybody. In this lecture, we are going to study ambiguity for context-free grammars. We have seen so far context-free grammars. Remember, a language is context-free if it is recognized by a context-free grammar. And we have seen several examples of context-free grammars. Now we're going to study an important concept, which is ambiguity. Ambiguity is when some string in the language may have multiple derivations in a context-free grammar. Ambiguity is a problem for compilers. Why? Because compilers use derivations to give a meaning to a string. A string at the beginning is just a bunch of symbols, but it is used to give meanings. For example, the meaning of a string 1 plus 0 times 0, which is just, again, a bunch of symbols, is its value as a number. Now, if there are two different derivations, then this value may not be well defined. For example, the string 1 plus 0 times 0 has two derivations in this grammar here, which we saw earlier. One derivation starts by expanding s into s plus s, then replacing the first s with a 1, then expanding the second s with a times, replacing s with 0, and then again with 0. Let's now try to find the second derivation. Can you guess how we can start with? Can you guess what we can start with? We can start by expanding s into s times s. And then we can replace the second s with a 0. And what next? Now we can expand the first s with s plus s and further replace to obtain the second string. These are two different derivations, and if you think of the sequence of steps as the order of operations, you can verify that you will obtain two different meanings, two different values for the string. Okay? Because if I first do the multiplication here and then a sum, I get 1. But if I first do the sum here and then I multiply everything by 0, I get 0. So now we want to define context-free grammars with no ambiguity. We're going to define that a derivation is leftmost if at every step the leftmost variable is expanded. For example, the previous derivation, the first one, was leftmost because we were always expanding the leftmost s. And we define a context-free grammar to be unambiguous if no string has two different leftmost derivations. Let's give an example. This context-free grammar here is ambiguous because the string 1 plus 0 times 0 has two distinct leftmost derivations. This is one leftmost derivation, and this is another one. They're both leftmost. If you think of a compiler, naturally the compiler can proceed by leftmost derivations. So if there are two different derivations, the compiler may be in trouble when trying to assign a meaning to the string. Well, how do we fix that? Instead of using this context-free grammar here, which is ambiguous, we are going to use another context-free grammar which recognizes generates, which derives the same language, but is unambiguous. And here is the grammar. We can generate the same things, but it is now unambiguous. And now this string here would have a unique leftmost derivation. So what is it? This derivation will force us to pick an order for the operations. You guess? The first step is to expand S into S plus T. Now we have to be leftmost, so we're going to do what? We're going to expand S into T. And then again, we have to be leftmost, so this T has to be expanded into F, and finally F into a 1. Now we have 1 plus T. So what do we do now? This T now can be expanded to obtain 1 plus T times F. Now this first T can be expanded into an F, and then F into a 0 to obtain a 0 here. And finally, this F here will become a 0. And this is the unique leftmost derivation for the string. And this issue of ambiguity is really, really important. So the context-free specifications of languages, like programming languages, has to be unambiguous. So a lot of work is put into making grammars not ambiguous. This is a snippet of an actual specification for the Java programming language. And it is a bit cumbersome, but the reason why it's so cumbersome is also because it has to be unambiguous. So you have things like a multiplicative expression and an additive expression. So the additive expression can become a multiplicative expression, but not the other way around. And this forces an order in the derivations, which makes the grammar unambiguous. And that's it for now.